I'm Swapnil Bhartiya and we are here at OpenStack Summit in Vancouver, and today we have with us Tim Bell again from CERN. What is your kind of rollover, and how well versed you have to stay with all those technological changes, or you have minions who are doing everything for you?
I think from the point of view of my activity, so I look after the team that manages the compute and monitoring infrastructure at the data center. So it's a team of about 55 people, of which only part of that is the cloud. The other areas run the high performance batch systems and the configuration management and Linux support. In terms of how to keep up to date, events like the OpenStack Summit is a great way. I try to get in to listen to talks, get along to the forum sessions and discuss, but equally going back and watching the YouTube videos when they're recorded is a very good way of selectively keeping up to date.
Right.
The other thing that I do is, as a member of the OpenStack Foundation board, I'm an elected member by the community, and that also allows, it's a very good way of keeping in touch with what's going on in industry. Since one of the aims of the CERN collaboration with industry is to make sure that the things that we are doing are relevant to industry and have applications in that environment. It's a way of us giving back.
When you talk about the trends, what are the trends that you are seeing which can benefit CERN?
I think the whole movement around Kubernetes as a federation vehicle is a very interesting development. The idea that we can use Kubernetes to hide from the end users where we're provisioning resources. So whether we get a Kubernetes cluster in the Open Telecom cloud, whether we use it on-premise, allows us potentially to be looking at, as we get into burst activities, using external public cloud resources, but equally during quiet times, scaling back and using the on-premise resources. So that's been a very interesting set of developments that we're keeping close touch on through some European Union projects.
So tell us about what new is happening at CERN when it comes to all the cloud and containers and all those new things.
Right. So this year we've now started up the accelerator again. So we'll run for the remainder of this year, and then after that we'll have 2 years during which we'll do some upgrades for the next run. So already the data is pouring in around a petabyte a second or so into the CERN cloud.
Petabyte a second?
Yeah.
Oh wow.
So it gets filtered down along the way, but we're already now into data taking mode. But as part of that, we're also researching and preparing for the computing environment for the next run, which will start in 2020. So at that point, we're starting to investigate container technologies, in particular the ability to run physics applications in containers. So as Ricardo Rocha demonstrated this morning, we can run physics analysis now, not only on top of the CERN cloud, but actually using federated Kubernetes across multiple clouds. So he was demonstrating cloud applications running with the Open Telecom cloud in T-Systems and the Google Compute Engine along with running on the CERN cloud. And we do that using the OpenStack Magnum project, which basically gives you a Kubernetes cluster with a single command line. So that's really transforming the way that we're thinking about how we deploy services for the future, but at the same time we have to maintain the environment that we have for the services that we're running today.
Serverless is becoming a big buzzword these days.
So we're starting to look at usage of serverless and of machine learning. So there's a difficulty of using machine learning in particular as we start to look at doing research. The difficulty is you can't train anything because you don't know what you're going to discover.
Yes.
So when you don't know what the Higgs Boson looks like, how do you train something to look for the Higgs Boson?
True.
But you can train things to look for anomalies, and then after that reduces the work for the researcher. So we're exploring around GPUs, TensorFlow, this kind of software to see, are these usable in high energy physics as well? The overall structure has not changed dramatically. It's been largely a question of just increasing the size of the cloud. We're at about 320,000 cores at the moment, about 9,200 hypervisors. And we'll gradually continue to expand that, adding more and more of the bare metal side of things. So this is the database servers and the disk servers, in addition to the compute, over the next year.
Okay.
But then during the shutdown period, it'll be largely a question of building up the technologies for the next run and doing a lot of testing.
Is machine learning being used only in to find anomaly, or also because you're doing a lot of data processing, which is a
Right.
lot of kind of manual work or whatever.
Yes.
Is there?
So there is investigations of the use of machine learning in many areas. It's still quite a new technology, and it takes
Right.
a while to apply this to the research use cases. And especially when there is data taking going on, then a lot of the emphasis and the effort is being put on making sure that data is recorded and processed correctly. But potentially during shutdown periods, it also allows people to have a look at new technologies at that point.
When will be the next shutdown and upgrade cycle?
So the shutdown and upgrade will start at the beginning of 2019 and go on until the end of 2020.
Okay.
And then after that, we'll start in what's known as Run 3 with the higher intensity of collisions.
So is this the only window that you can explore and then deploy them, or you just continue to do it throughout the year?
So we're generally constantly exploring new technologies, but if we want to do significant change, then at that point, that's when we start to bring it in over that period, since we aren't faced with the deluge of data coming from the accelerator. So for example, in 2011, 2012, when we first did the OpenStack deployment, that was a very natural point at which to bring in tools like Puppet, monitoring like Grafana and Collecti. And making those kind of significant changes to the infrastructure.
Okay.
But there's all constant incremental change. I mean, we follow OpenStack releases. We're now running the Queen's release. So that requires constant upgrades while we are online.
Last time we were discussing that you are collaborating with Square Kilometer Array.
That's right.
So what kind of work is going on by this time now?
So with the Square Kilometer Array people, we've currently got 4 areas of computer research that we're investigating. In particular around preemptible instances, where the aim is to be able to start up virtual machines but then stop them abruptly when there are higher priority activities that come along. This allows research clouds to fill up to a large degree of utilization, and equally commercial clouds potentially to use their spare elastic capacity and monetize that in a similar way that the Amazon spot market does.
Okay.
The other area is bare metal container orchestration. So we're looking at how can we be using containers on bare metal rather than the current mode where we run containers on top of virtual machines, which gives us very nice isolation. But some applications are interesting, especially the high performance ones, and therefore it's interesting to have a mode where you're provisioning through Magnum on top of Ironic rather than taking them out of the virtual machine pool.
What is your biggest challenge, compute or storage?
We've got challenges in all the areas. I think at the moment, when we look at where we need to be going forward, storage is probably of a more complex system than the compute. The compute models have been worked out over the past decades. And although virtualization has changed our efficiency in delivering that because we're now able to be software defined, the storage area still remains a problem, especially as we start to see the spinning disk capacities flattening out. How we address potentially a 60 times increase in storage within the next 5 years is one of the worries. Find the right balance between tape storage, which is cheap, but takes a while to get at, and disk storage, where we have the fast capacity, but you have the limitations of it's a more expensive medium.
Right. Everything is becoming software defined.
Yes.
So what does that play?
So for us, this allows us to invest significantly in automation. So already the compute infrastructure, when there's hardware errors detected by the monitoring systems, we can immediately be withdrawing those hypervisors from the pool, scheduling the workloads elsewhere. But also going further, we're starting to look now at the software-defined networking side of things, and in particular there, currently we run a very flat network structure. There's not a significant amount of tenant isolation. The data is available to the general public, and therefore there isn't a need to isolate out.
That's not it,
But we're finding more and more cases of things like Internet of Things that need to have the surveillance cameras isolated from your main network.
Right.
And there we start to now explore some of the more sophisticated uses of Neutron to deploy those for our cloud. We run a basic flat Linux bridge structure, but we are exploring packages like Tungsten Fabric in order to be able to be producing tenant isolation for the pension fund or the medical systems or the surveillance cameras.
Eventually, do you think you will need a whole planet for yourself to store?
I think one of the benefits that we have with public clouds coming along is that we aren't just limited to the available capacity at the CERN on the CERN site. We're already sharing with 170 universities and labs across the world and using their resources.
Right.
But we'll be able to also exploit public cloud resources as they come.
Does it create any risk for?
So we have a very open data policy.
Exactly,
We're very keen on open access publishing. So you ought to be able to read the results of the papers that CERN have done. But also you ought to be able to come along to portals like the CERN Open Data Portal and then run your physicist for a day simulations, which actually uses resources out of the OpenStack cloud. So we're very much in a mode where, in order to engage with the community at large, you also need to put yourself in the role of physicists, and we produce courses for high school kids, for university students to learn by running through the same discoveries that we ran through to find things like the Higgs boson.
Do you see there is a kind of crisis of people not taking interest in their science or technologies? Young kids, they are mostly spending time on iPad. Do you see that is a problem today or not, from your perspective?
I think it's very important that we encourage the kids of today to come along and have a look at science, especially fundamental science. There are many possible career directions, and we run programs for schools, so 80,000 school kids come through CERN each year, along with systems where, for example, physics teachers of countries get nominated and win prizes and can come to CERN. And so it is a very important part that science should not just be something which is separate, but people ought to have it as an accessible environment. CERN is actually one of the top tourist attractions in Geneva.
Yeah, I know.
And anyone can come along for a visit, have a look around, see the first World Wide Web server. And next year we're having an open day during the autumn where people will be able to come along and go underground to actually see the detectors up close.
Do you work with the schools and universities?
We also do explicit programs with the universities, outreach activities, and also there's lots of opportunities for students at various points of their university time to come to CERN. So in a few weeks' time we'll be welcoming over 200 summer students who come to work at CERN for 9 weeks during the summer and get a chance to be exposed to the physics and the computing and the engineering as well, because it's not just physics.
And when you talk about new technology like serverless, these are new technology, how can you get developers? So do you also feel kind of that, there are not enough developers? And if you do, is CERN doing anything to encourage more people?
So where we normally find is when we go out to recruit, then we're really looking for people who are able to adapt and rapidly adopt new technologies. So it's not so much what people have done, it's more of have they shown and demonstrated the ability to learn new technology. If you have a career at CERN over 30 years, then the technologies will change dramatically. 30 years ago it was the mainframes. So to have people who can adapt to change is as much as an important feature as to whether they know Spark or serverless.
All the engineers who are working on CERN project, all they are employees, or there are a lot of volunteers also, or other companies or organizations, they kind of dedicate some developer resources to CERN? So
people who are actually working at CERN are a mixture of people employed by the organization, sometimes on shorter term contracts, others on longer term contracts. There are visitors who come to CERN from universities, but also we have various collaborations with industry. So there's one going on at the moment with Huawei around OpenStack, where Huawei fund some people to work at CERN on the challenges of the LHC at scale, and then with that, then it means that when industry needs that functionality, it's there and working. So we use today's challenge from the LHC to solve industry's challenges of tomorrow.
So what does Huawei or other companies get out of it?
They're able to be working with us so that their products, their software, has been validated at CERN level scale. And in general, if something is working at CERN with the challenges we've got, you can be fairly confident that it'll work in that environment. But in the case of Huawei, we're actually working with the upstream open source communities. So everything that we do as part of that collaboration is then contributed back to OpenStack.
So you said outreachy, so what kind of efforts are going on?
We'll often have situations where, for example, CERN people will go to one of the CERN member states for a period of time, do road shows. And equally, we have situations where people who have come to CERN for a short period of time will then return back to their home countries with a set of additional skills like OpenStack and Puppet and Linux. And then from there go and work within the areas of industry where those set of skills are in demand.
Do you watch Black Mirror?
Yes.
When we look at science fiction, sometimes it's like mostly dystopian instead of also looking at the positive aspect of science. Why is the reason that mostly science fiction is all about how things can go wrong?
I'm not sure how much television has different applications of different areas of interest. I think it's always good to see potentially the areas under which we do need to be careful as we progress. But equally, I think looking at things like that come out of science on the positive side is also one of our jobs. People coming to visit CERN in order to see the optimistic side of science and the benefits in terms of things like the magnet technologies that go into the MRI machines at hospitals. So there's a lot of positive evolution of science, and there's nothing more impressive than seeing a cathedral-size, 7,000-ton piece of scientific equipment to really get into this.
I think we talked about so many times. We also went off topic, but I think it was fun talking to you, and I look forward to meeting you again next time.
Great to see you.
Thank you.